After the exploration we did the last time we had notes, I feel like graphing absolute value functions by hand is going to be pretty easy. I'll be referencing this formula a lot today. And I'm actually going to write it a little bit bigger over here so we can look at it more closely. Remember that H controls the horizontal movement. And if you remember, it's backwards or opposite. And the reason it's opposite is because in this formula, it says minus h. So if h is a positive number, it'd be minus a positive number. That's why we move to the right. If h is negative, it would be minus a negative, and it would look like x plus h, and that would move it to the left. So remember, plus moves the graph to the left, minus moves the graph to the right. K is responsible for vertical movement. So the graph has a vertex at HK. Noting that H is going to be the opposite of whatever you see in the absolute value bars. These other bullet points are just reminders from Friday. So the graph is V-shaped. It opens up if A is positive. It opens down if A is negative. If that A value is a fraction or a decimal less than 1, the graph is going to be wider. And if the graph is something, if A is bigger than 1, like 2 or 3 or whatever, the graph will be more narrow. So in number 5, there's a couple ways to write down what the vertex is. One way is to think about what do these numbers mean, and then get that written down as a point. So what does the plus 2 in the absolute value bars, what does that plus 2 represent? Right or left? Left 2. And the plus 3 indicates up 3. So because we're moving left 2, our h value is actually negative 2. Our k value is positive 3. Our vertex is at negative 2, 3. From the origin, left 2 and up 3, there's our vertex. What's the a value for this particular equation? Negative, so negative 1. This means, and those of you in class get the visual, if this is the vertex, we're going to move down 1, out 1, down 1, out 1, down 1, out 1 to form that V shape. So from our vertex, down 1, out 1, and you have to go in both directions to make that symmetrical V shape. From that point, down 1, out 1, in both directions, and so on, and so on, and so on. Do we need to do example 6? Let's skip to example 7 and see how that goes. Some of you are going to pick this up really fast, and you'll be able to look at this and immediately see that the h value is positive 1. But it is perfectly fine if you need to think about what does this mean inside the absolute value bars. If it says x minus 1, which direction are we moving? Right 1, because it's backwards. It's crazy town. If it says minus, we're actually moving to the right. How much are we moving up or down? Is there anything after the absolute value bars? No, so it's like there's a plus 0 there and they just didn't write the plus 0. So our vertex, instead of being at 0, 0, this vertex is going to move right 1, 0 up and down. So the vertex is 1, 0. What's the a value for this particular equation? 2. And technically, we're not supposed to think about a as a slope, but unofficially, it's like the slope. So think of it as 2 over 1. From this vertex, we are going to go up 2, out 1, up 2, out 1 to make that V shape. So from our vertex, up 2, out 1, up 2, out 1. Do you feel confident trying number 8 on your own? Try number 8 on your own. There's no number inside the absolute value bars that indicates no side-to-side movement, so our vertex is still going to be centered on the graph. It says +1 after. That means we're moving up 1, so our vertex is at 0, 1. Our a value is -2/3. So that means from this vertex down 2, out 3, and again. And notice when it's a fraction like this, it makes a much wider V. The sides of the V are less steep. On your assignment, the last 2 problems are going to say specifically that you will not get credit for the entire assignment unless you attempt the last 2 problems. So here's what the last 2 problems might be. Let's say it was this exact same function, but instead of an equal sign, we have a greater than or equal to sign. So think about, should that boundary line, should that V be a solid line or a dashed line? In this case, it would be a solid line. And then greater than, should we shade up or should we shade down? Greater than, bigger, up. Or pick a point like 0, 0 and test it in the inequality. If it makes a true statement, shade that side. If it makes a false statement, shade the other side. But greater than, we would shade up, so you'd shade all of this area above our boundary line graph. So it's just asking you to take what we did with inequalities and what we just learned with absolute value graphs and just kind of put them together into one thing.